Welcome to this video presentation on drawing structural organic formula. In this presentation we will define the terms molecular formula and structural formula. We will describe the difference between full and condensed structural formulas. We will show representations of functional groups and condensed structural formula, and practice converting between full and condensed structural formula. Let's start by looking at what a molecular formula is. A molecular formula is one that shows the number of each type of atom that's present in the compound. So a molecular formula for butane would be C4H10, meaning there are 4 carbons and 10 hydrogens in the molecule. For ethanol, shows there are 2 carbons, 6 hydrogens and 1 oxygen atom. Aminoethane with C2H7N would have 2 carbons, 7 hydrogens and 1 nitrogen in the molecule. These type of formulas are very common for inorganic compounds like sodium chloride or magnesium sulfate, but they're not very helpful for organic molecules as they tell us nothing about the structure of the molecule and the way that those atoms are bonded together. And so for this, we need a structural formula. A structural formula shows the arrangement of atoms within the molecule. There are many different types and combinations, and here are a couple of common examples of large compounds present in our world. These are both structural representations of the molecule. Let's start by looking at a full structural formula. This is one that shows all atoms and all bonds. So this molecule here, which is butane with 4 carbons and 10 hydrogens, shows the 4 carbons joined in a line and the hydrogens filling up the bonding spaces. This molecule here, which is propanol, which has 3 carbons, 8 hydrogens and 1 oxygen, are arranged in this way. This molecule is aminomethane with 1 carbon, 5 hydrogens and 1 nitrogen, and they're joined together in this arrangement. Sometimes molecules have a double bond in them. This molecule here has 4 carbons and 8 hydrogens, and it shows a double bond between the 2 carbon atoms. And this molecule here is methanol with 1 carbon, 4 hydrogens and 1 oxygen, and they're bonded in this arrangement here. So a full structure shows all the atoms and all the bonds present in that molecule. There's another type of structural formula called a condensed structural formula. They're often called constitutional formulas, so you need to be familiar with this term. A condensed structural formula is like a shortcut, which is much more convenient when you're working on a computer. So we'll start by looking at butane with its 4 carbons and 10 hydrogens in this full structure. If we were to condense this, we'd write a formula like this: CH3, CH2, CH2, CH3. So as you can see, what we've done is condense down each section of the molecule as a small group and then join them together. And you can see this is much easier to type on a computer. This molecule here, which is ethanol, would be condensed to CH3, CH2OH. In condensed structures, molecules that have groups or branches on them are often shown using brackets. So this molecule here, which is methyl propane, has a methyl branch or group here. So if we would condense this molecule, we'd put that inside a bracket. So it would be condensed to CH3CH. We'd put the CH3 group in a bracket and put the CH3 group on the end. Likewise, this molecule here, which is propane 2-ol, the group or branch on the molecule is an OH, so we can condense that to CH3CH, put the OH in a bracket, and put the CH3 on the outside. If our group or branch on the molecule is a single atom like a chlorine, we don't often use brackets for them because they're not needed. So this molecule here would be condensed to CH3, CHCl, CH3. You could use a bracket around the chlorine if you wanted, but it's not necessary, so we leave it out. The last type of structure we look at is affectionately called a skeleton structure, and they're most common for very large molecules. No carbon or hydrogen atoms are shown in skeleton structures, so they're very useful for very large structures like this fat molecule. As you can see, the zigzag structure on this molecule has no atoms in it. Every corner of the zigzag represents a carbon atom, with its 2 hydrogens bonded to it as well, so they're omitted just to make the molecule a bit tidier. This large organic molecule is typical in a biochemical system. As you can see, most of the carbons and most of the hydrogens have been omitted, just to make it tidy. but each corner of the zigzag represents a carbon group with its attached hydrogens. Sometimes we just leave the carbon groups on the end and zigzag the rest of the structure. Or sometimes we don't put any hydrogens at all and just show the carbon backbone. And quite often in organic chemistry we have combinations of all these different structures. There is more than one way to write an organic molecule. So we can have a combination of condensed structures and skeleton structures all joined up together, and they're all useful and they're all relevant. You must be aware that no skeleton structures are acceptable in assessments and exams. All atoms and correct bonding must be shown in an examination. So they're okay for shorthand and they're okay for classwork, but they're not okay in a formal assessment. So while we're talking about that, let's have a look at some examples of what is acceptable and what isn't. We're going to use the example of ethanol. Here's a condensed structure for ethanol showing its CH3 group, CH2 and its OH on the end. We could also show ethanol like this by putting in some of the bonds. Or we could put the OH group on the side, that's okay too. Or we could draw a full structure, put the OH group on the end, or we could draw it around the other way and put the OH group on the other end. All of these molecules show the correct atoms and the correct bonding order, so they're all acceptable in exams. Let's look at some structures that are not acceptable for ethanol. This structure here has missed off all the hydrogens on the carbons, so it doesn't show all the atoms or all the bonds, so that would not be acceptable. And this structure here shows all the atoms in ethanol, but not the correct bonding. This one shows an incorrect bond between carbon and hydrogen, so this would not be acceptable. Likewise, this is very similar. It shows ethanol, but it's showing the carbon bond going between the hydrogen and oxygen atoms, so it's a little bit dodgy and would not be acceptable. Likewise, this one here also shows the carbon going to the hydrogen instead of the oxygen atom, so this structure is not acceptable. Now take care when drawing organic structures that you are doing them correctly. Try not to get into bad habits early and do incorrect structures in exams. It is quite disheartening when students draw an incorrect structure and are marked down for it. So don't let that be you. Lastly, we'll just have a look at the way some functional groups are written in condensed formulas. This is an alcohol, and an alcohol is written as an OH group. This molecule contains a carboxylic acid, which is this functional group here. So this is condensed to COOH. This molecule here contains an ester group, which is similar to a carboxylic acid. So again, we condense that to COO. Quite often in alkenes, we condense the molecule down but leave the double bond in to show the correct bonding. This molecule contains an amide functional group, which is this one here, so we'd condense that to CONH2. And lastly, an aldehyde, which is this group here. So this would be condensed to CHO. This is a tricky one to remember because quite often students write COH, which is trying to indicate an alcohol group. As you can see, the difference between an alcohol and an aldehyde are quite different. So it's important that if you're using a condensed formula that you get the atoms round the right way. If you're not confident with condensed formulas, then my advice to you is not to use them. Draw out full structures instead. Let's do a bit of practice. So in this slide I've got 6 molecules. So you should pause between each one and have a go writing down the condensed structural formula and then replaying the video to see if you've got it right. Start with this one. How did you get on? This last one's quite tricky. There is more than one way to write a condensed structural formula and still be correct. The important thing to make sure is that you've drawn all the atoms in the correct bonding sequence. This is just one version, but I'm sure there are others and I'm sure you've got them right. If you're not sure, get your teacher to check your answers to see whether you've written a condensed structural formula that correctly shows the bonding in that molecule. Now you should practice some of the examples in your exercise books and workbooks so you can get confident at switching between condensed formulas and full structures.